Welcome you to the next session of embedded software testing unit 5 series. This is regarding test management lecture 3, and today we study about change management, incident management, revision history, CM tools, a few examples of configuration management tools. We will have a look. Before that, we will try to go through what we had studied in the previous session. We had gone through some of the activities of configuration management, in particular SCM. It is called software configuration management activities. So it involves SCM planning, SC identification, that is configuration identification, software configuration identification, and there is a term called baselining and software configuration control. So basically what we do here is the life cycle changes we will manage. Basically it is getting controlled. So there is a dedicated person for this who is called as admin or configuration controller. Basically he can also be a member of control board, configuration control board it is called as. So they will basically decide on the changes and the impacts, what is the kind of modification, either to accept, reject, or to refer it. All this they will decide. So this is an important aspect of SCM activity. Next we have studied about software configuration status accounting. Here basically what we do is we will get the complete information about the configuration of the entire project lifecycle items, specifically the CIs or the configuration items. It maintains the information about the configuration documentation. Configuration documentation basically will have all the CIs list, folders, where is the location, what is the baseline, what is the revision number, all the information about that will be there part of the configuration documentation. So this configuration documentation will be maintained inside the configuration status report. That status report is nothing but the activity is called as software configuration status accounting. It also maintains the information about the product's operational and maintenance documentation, how we are going to carry out. So what are the current information that is available, what are documents affected by the changes, and those changes, whether what is the status of those, whether they got updated or any changes are in progress. All this status about the configuration, each of the configuration identification elements will be maintained. And also it enables a retrieval of information concerning change decisions and provides a source for configuration history of a product, like what is the history behind all these changes, and its configuration details will be provided by this status accounting. And all the data collected during configuration status accounting is maintained in configuration status accounting report. So there is a frequency like bi-weekly or monthly wise this report will be generated. This report generation is also part of the configuration status accounting report. Basically this collects for that particular month whatever the configuration items undergone changes, updates, impacts, all this information will be reported. Configuration status accounting helps in establishing the establishing and maintaining the configuration records for CIs. The next activity we went through, the last one in the same activity is nothing but the software configuration audit. So how the configuration accounting and the CIs are getting maintained. So there is an independent audit conducted by few auditors. It can be from the same organization or from an independent team or outside, or it could be from customer also. So there is a representative. He will have his own checklist and guidelines against which he will go through, and all these guidelines, standards, plans and procedures will be part of the plan. The plan is nothing but what we studied about is SCM planning. The plan will tell so at what frequency what will be maintained, what are the CIs, all this. Against that, whether are these being clearly maintained and tracked under the SCM activities are being audited. that is nothing but software configuration audit. So a software configuration audit performed independently to evaluate the conformance of software products and process to the standards, guidelines, plans and procedures. So there are basically two types of audits which you have studied: functional configuration audit and physical configuration audit. FCA is done, functional configuration audit is done to ensure that configuration item to audit is consistent with its specification, and physical configuration audit is going to make sure that the design and reference documentation is consistent with the built software product. So whatever we spoke about folder structure, versions, baselining, all these activities, physically they are available in the configuration repository, is part of the physical configuration audit. Then we went through few example lifecycle CIs and the baseline, various baseline events that are going to happen for that particular CI. For example, project environment is also can be a CI. As and when it is identified in the project, suppose some new tool, new configuration data from customer or some technical documents arrived, that also will be part of the CI list, and it has its own chain of approval and all that mechanism. Based on that, that is called as a baseline event, and particular baseline event will identify that particular configuration identification item. Then we went through the SCM phases, which are nothing but initiation, planning, execution and closure. Initiation, basically we start the project, we do this, we appoint the CC configuration controller, we appoint the chain control configuration controller board. We also conduct CC training as part of the configuration controller and the CCB. CC training basically takes care of all this project related configuration details, how it is going to be maintained. This will be general as well as specific to that particular project. And the next one is the planning. So we do the identification of CIs, we write the procedure and naming conventions, labeling mechanisms, versioning, review and baselines, all this will be part of the planning. Then we will have the execution. So whatever the issues that we go through during the CM or the audits, we are going to correct it. So that correction and changes are part of the execution. Closure is upon the SCM closure. This is basically going to happen when we have the project getting identified as a closure, and we will identify a closure meeting, and during that meeting we will identify with our stakeholders what are the things that are going to be returned, what are the things that we are going to return, in the sense we are going to close the licenses or we are going to archive um, uh, the files or the database or the any repository elements, and any materials that we need to return back to customer, all this will be part of the SCM closure. So also went through some of the example like objective scope, what we are going to do for the SCM process. The process task will establish the CM environment, identify CIs, create intermediate and final product baselines, raise CRPR for modification of software lifecycle item. CR is nothing but change request, PR is nothing but a problem report. Change request could be an enhancement or new features. PR is nothing but a problem report due to an issue or error in the existing element of the software lifecycle. This PR will be raised, and PR has to get approved or rejected by the relevant stakeholders such as customers, and the changes will be analyzed and the impact will be approved by the CCB, which is nothing but the configuration controller board, control board. And there is a dedicated person for doing the CM activities, as I said, who is called as a CM or SCM admin, who is also likely to call as CC configuration controller, who maintains and do a retention mechanism of all these data elements of the SDLC, software development lifecycle, by him. So basically status accounting keeps track of CAs, delivered products, when it was delivered, what are the changes, what are the change requests, what are the approved requests, all this. And we went through configuration item versioning. This is a very important aspect. Here we identify as a draft version, baseline version, minor changes baseline, and major changes baseline. So the drafts will be usually in terms of fractional elements like 0.1, 0.2, etc. Baselines will be 1, 2 in increments of the integers. It will be done, and any intermediate versions we are going to keep track of versioning in 1.1, 1.2, etc. Major changes or major baselines or levers will be done with the help of the higher increments such as 1 to 2.0, 3.0, or 10.0, 20.0, etc. It is depending on the project nature, complexity, and the release mechanism. Next, the thing that we studied is about baseline, minimum baseline, and intermediate baselines. We are going to have it. This will be keep on happening during the project life cycle. So the project life cycle items will have a testing baseline, design baseline, and SRS baseline. All this will be part of the configuration item. Also, we studied about a workspace, how it is going to be maintained. There is a repository, and that repository will be used for adding the files or taking out the files and updating it and adding again. This process is called check-in, check-out, and the files are getting inspected or used by the verification team with the help of his workspace called verification workspace. So that's what we studied in the previous class. We go through the change management aspects in today's session. Change management. So what is change? Change means any update or request for changes that are going to happen on a specific item. That is something like a living document. That is something like a living code. That is something like a living deliverable. This is all part of the change. And how are you going to manage it? How are you going to maintain it? It's all part of the change management. So we receive a request for change, that is called a change request. First, what we are going to do is we are going to document it, and complete change cycle change management will happen with the help of the below items. We analyze the impact of the particular change request. We are going to approve for the analysis what is the impact is going to happen, how we are going to change, and that should be approved by the change request approver. Those are nothing but project manager, who is also can be part of CCB, and minor changes of course at the project manager level it can be done. Any major changes it has to go through the CCB. Here major changes could be something like a major functionality or a feature or any optimization, etc. Minor changes are something like minor comments fixing, any documentation issues, documentation in the source code or like enough comments are not there, etc. Those kind of it is called category 2 changes, minor changes. The major changes are called as category 1. So likewise we are going to have the different types of changes. Accordingly we are going to get it approved by different team. One is by the test manager or the project manager, the other one is with the help of the board if it is a major change, and the board can also have a customer involved. So making of changes we do with the element, that element is already a CI. We are going to check out or we are going to take it out from the configuration repository. The repository will be maintained with different CM tools. We'll study about CM tools later. CM tools something like PVCS, JIT or SVN, VSS. There are a number of tools. Also we have MKS, etc. So majorly these are some of the repository tools that are used in the embedded automotive or aerospace industry, and we need to have a review of the changes that are required. And once we are done with the changes, the review comments will have to be reworked. Once rework is done, it is good for check-in, and we are going to check in with a new version number. So new version number we don't need to provide by ourselves. The tool will take care by incrementing the next number. That increment number, how it's going to increment, we are going to define during the configuration of the CM tool, the configuration management tool. Finally, we are going to have a change closure. This will be through project manager updates to customer or his workbook, whatever it could be. So that is what we follow in the change process part of the change management. Next, incident management. So what is an incident? Any significant unplanned event that occurs during testing or other event that requires subsequent investigation or resolution. It means something has happened. Let's define about that something soon. That something is going to cause during the testing or development. Basically, we focus on testing because our presentation is about testing, embedded software testing, and that changes or that incident requires some investigation and some resolution. Without that attaining to that event, we cannot proceed, or there are certain blockages because of that event. So that is nothing but an incident. So that incident could be something like during testing it can happen, or test case development it can happen, test environment it can happen, or test planning deviation it could happen. While doing the execution we can get it incidents. So likewise it is up to the planning how we are going to define the incident, or if an incident is unplanned, that also can be called as an incident, and under the incident management that has to be taken care. So something like differences in actual and expected test result is nothing but an incident. That means it is a failure. Possible causes: software fault, expected results incorrect, test was not performed correctly. So the most dangerous part is the third part. This is a true incident basically. Why? Because software test or embedded software testing is supposed to be done by the dedicated testers, and they are supposed to identify the faults or the errors in the develop the code, and according to the requirement and the design or whatever it is, they are supposed to take care of the identifying faults, and the test approach or the test strategy cannot have a issue itself, so that it's difficult to manage or control. That incident also need to be taken care. So the causes of an incident could be due to software issue, or a test is failing, or test is not done correctly or performed correctly. And incident can be raised against any code, any documents, or it could be any environment issue or anything that is part of the embedded software testing. That is what is called as an incident. Next one is the incident management. So once we have incidents occurred in the project, so how we are going to manage is what is spoken in incident management. So first we need to identify and detect and record it. What is the incident and complete details of that particular incident, the occur of the event, whether it is occurring again and again, frequency. So what is the surrounding conditions under which this incident is happening? What is the preconditions? During what execution this is failing? So who is doing? What is the responsibility due to which this incident has happened? Likewise, we have several identification and detection mechanisms that will be recorded. Once it is not going to analyze, it is just going to capture the first step. Then we are going to have a quick analysis and classification. We are going to prioritize. Suppose there are 3-4 incidents that have occurred. Depending on the priority, we are going to classify what sort of an incident it is, and we are going to come up quickly with a quick analysis of that particular incident. Then once we are done with the analysis, we are going to have an investigation and detailed analysis. So the second step is quick analysis. Next one is the detailed analysis. Okay, so once we have done with the investigation, the cause and the source of issue, it is something like problem report with a possible solution also. It will be part of that detailed analysis, and action will be taken care in next step called resolution and recovery. So how are you going to recover the future incidents? That is what recovery mechanism talks about, and currently occurred incidents will have to be addressed with the resolution that we have. Okay, and once we have the resolution available and the incident is no more, we are going to have an incident closure, and at any time it must be possible to see the current status of the reported incident. So once we have the incident reported, it will move into different states basically, or different stages basically it is called. The stages are again derived from the various actions that are going to be taken care on the addressed incident. So the incident is a new one, it is just open or reopened. The incident is under incident resolution, or incident is under wait stage or reject stage or fixed stage, or the problem is fixed. So the next stage is included to build. Once it is included, it has to be verified whether that incident is resolved. Finally, we are going to close it. So all these stages can be seen in the mechanism of the life cycle of that particular incident management. So this is part of the incident management, so that we know that what is the stage of the particular incident, and this is about statusing of the incident. We have the stages of incident recorded and reported. For example, in terms of the incident is just new occurred, the incident is accepted by the stakeholders, and incident is assigned to the person who is going to resolve it. The incident is in progress. The incident could be on hold because there is no solution for that, and temporarily it is working, or the resolution is not yet complete, or the resolution that has been done is not consistently working. So we can make it as a on hold sort of a status or the stage. Then the incident is solved and it is closed. So basically these are some of the incident stages that also can be used for incident management. So at times what will happen in the embedded software testing is suddenly numerous issues or incidents are going to occur. So definitely we are going to have a priority. So priority is nothing but we are going to assign priority for each of these incidents, and the priority is basically decided based on the impact plus urgency of that impact as well as the timeline that is required to get resolved that particular incident. So that is what we do with the priority, and accordingly all the incidents will have a priority. And other things like escalation metrics, escalation triggering mechanisms, and the incident please mind that incident could be testing issue, environment, suddenly some environment or some hardware has broken or crashed, which you need to escalate to the higher management, and higher management could resolve with an alternate mechanism, or you could talk to customer, whatever it could be. So all this will be part of the incident management. The escalation matrix it is called as in such cases. So there are relevant stakeholders that take care of the incident management. Okay. Any report that we are going to have in terms of configuration, change management, or incident management, or software configuration element, all this will have a heading called revision history. This is very important because it's part of the configuration. So we need to identify or highlight that particular configuration, what was done during the various revisions of that particular element. So here is an example that has to be there minimally in any of the artifacts. It can be any design document, requirements, test cases, test planning document, test environment index, test procedures. It could be test script or it could be software code. Anything should have a revision, and that revision should have a minimum elements such as the below 4 or 5 columns. So first one will have a revision number. It will increment as and when we get into the new revisions, and the date, author who is responsible for that revision, and who has approved or reviewed. I put an example, and what are the changes that has undergone during that revision. Like we have updates as per the new template. There is some new template that is moved, so that is going to have another revision because that revision will be mentioned as a new one. Likewise, we are going to have a revision history, and one more thing that we need to better consider is this month. Many people have seen it, again depending on the type of customer you have. European they follow with sorry, US they follow with month, day, year. Europeans and Asian countries they have a daily, month and year. So you have to be specific. Some countries I have seen year, month is also format they use. You can use a hyphen or slash or colon depending on the kind of customer. So you need to take care of all these things. It's very important. So for example, we are trying to send with the intention that May 5th you want to, or May 20th you want to deliver something. Suppose you have mentioned something like 20 or May 5th, May 10th, let us say. So you could have mentioned something like May 10th, 2014, but the customer thinks that wrongly it's mentioned because it is not matching the format that US people they follow. So similarly, we cannot afford to have 05/10/2014 for our customers where we want to highlight 10th May. So this is also very important. So we need to take care of these things when we are interacting with the customer in terms of clearly mentioning what is the revision that is taken place in that particular configuration item. So that needs to be spoken accurately. This is very important. Okay. So the next one is we have studied about the configuration management, incident management, software configuration management having 4 phases and 5 stages, 5 types of like planning, CI, status, statusing and audit. All these have to be maintained through a repository. That repository is nothing but a database or a physical location. How are we going to maintain that physical location? How are we going to address that? So we use tools. Various tools are there which will take care of this configuration management. That is what we study in CM tools. All testware has to be stored in a proper way. After quality checks, the testware should be frozen. You know what is testware? All the artifacts of the testing element will be part of the testware. Once the artifacts are ready for some stage, it has to be frozen to move for the next stage. The next step is to make the testware configuration items and store them in a configuration management tool. That means we are using a tool to configure it in the particular location or in the server. In addition to the regular testware, test cases and test documentation, the description of the test environment, tools used, calibration reports, and specially developed stubs, any drivers and simulators should be subject to configuration management. All this, any tools, any documents, anything, environment, even your wiring. Here, wiring or the hardware changes or the hardware board, you may ask how it is going to be configured. So definitely that hardware will have a circuitry. That circuit will be nothing but a diagram or the design. So that design is part of the configuration item, and any picture regarding that PCB or any parts, something like discrete or analog switches or the potentiometers. These also can be configured with the specific version and the vendor and other details, or if it is supplied by the customer, that also should be configured. All this will be part of the testware, and we need to have a configuration management with the help of configuration management tool. A configuration management tool provides the functionality to keep track of the configuration items and their changes. So why it is important is we need to have a track of which configuration we are using it and what are the changes that is going on. Currently what is getting used in the project, which version of the piece of the tool we are using it. So all this has to be maintained, and that maintenance will be through the help of CM tool. And examples of CM tools: PVCS dimensions, MKS, SVN, etc. These are typically followed in embedded industry such as aerospace, telecom, automotive. There are various other tools, case and all that. Depending on the sort of customer and projects that is being outsourced or developed by that organization, they will use it. And sometimes it may happen such that the configuration tool that the offshore team uses could be different than what the customer has. So it will be tricky to maintain both the versions or deliverables to the customer. So we need to take care of such things when we do the project planning or the configuration management planning. This will be in coordination with the customer. Similarly, it is difficult if you use a different version of configuration tools as well. It's also important across the geography. That means we have a server one place, we have a client at different place, and both have a different versions of the tool that is being used. We need to take care of the differences, or we need to have the upgrade or downgrade of the particular tool so as to take care of these differences. That's one important aspect of the configuration management. Okay, so we'll try to study a little about an example of a CM tool, which is called as PVCS dimensions. It is a web-based as well as standalone application. Both are there. Depending on a person and all this, they will decide what should be used and what should be installed. And this basically maintains all the repository, its configuration versions, history, checking checkout details, adding new items. All this will be part of the activity. That activity can be taken care with the help of the previous dimensions too. You can see this has a menu of various options, and this is an example of a payroll. And this is a toolbar with that icon, you can use it. And basically, the left hand side of this tool, you can see the folder or the folder structure where the CIs or the configurable items are available. And we have the status of whatever the items that we have clicked or used will be available in the status bar. And on the right hand side window, you can see the project name and the project location, working bench, customer, local, whatever it is, working on which version. The working on is nothing but the specific item which this particular window has opened. That is change request 18 or whatever it could be. So any update to these elements or the configuration items that are going to be placed here definitely will have some issue in terms of identifying it because of what or which I am going to use this tool, which is nothing but it could be a change request or a problem report, or it could be any failures that is resulting in using this tool for checking in, checking out and all that exercises. Here you can see baselines, and all the baselines are listed, and each baseline can have sub baselines. You can see payroll applications, payroll backups restore, payroll calendar, database, huge repository. This can be maintained. If you have just a local C drive or D drive to maintain all this, and you say that tomorrow I'm going to maintain through Excel sheet and through my own local modifications, it is very difficult and tedious. If you do it for hundreds of people or hundreds of software artifacts or hundreds of testing elements, if it is one or two, definitely we can maintain it, and it is difficult as the configuration items creeps up. And it's also important that we need to retain it in terms of retention. Why? Because the CIs are supposed to be maintained throughout the project as well as post project in terms of warranty, maintenance, whatever it could be, or a reuse for the other projects, exporting, importing, and all this stuff. So definitely there is a need of configuration management tool in embedded software industry or the project. It's a 100% mandatory to follow it, without which the clients will not agree. We need to have a planning for this. So this is basically the PC's dimension 2. We need to have the related project specific items listed on the folders, and each items will have intermediate versions or major versions or a baseline version. All these have to be specified in the work instruction. According to the work instruction, the configuration we are going to configure the tool, and it is going to take care throughout the project. Okay, so that is about the configuration management or the change management and incident management and the CM tools. Next we will come to the next part is called as test management. So test management is nothing but testing the project and how we are going to manage it. So how we are going to manage it? Planning of the test project, which is nothing but test management. So we have test management in terms of various activities: activity test plan, planning and control, test management itself, test configuration management, methodological support, preparation phase, specification phase, execution phase, and completion phase. So we are going to have a test management identifying all these artifacts in terms of planning of the various these items, and we are going to identify the start date, end date, total management effort, that is test management. You can see the abbreviations of each of these. PME is a test management, MSc is milestone or methodological support, TS is technical support. These are basically the different activities for each of the test artifacts. TCM is nothing but test configuration manager. TST is a tester, so which identifies the various efforts and the efforts during certain period. So these are all will be part of the test management. Basically, this will be part of the test project initiation and planning. So once we have done with this, we are going to manage the entire project with the help of these artifacts. We are going to track and maintain it. Okay. So test process, we know that test management we have, and we have the test processes which has its own life cycle model, and we try to align the test process in terms of software V model. So in our previous another session we studied about V model, multiple V model, nested V model and all that. So similarly test is also a part of that V model, and we take an example of this figure from that book from Bart Brookman and Edwin Motenboom. In this figure you can see that multiple V development life cycle where we have modeled where we have depicted 3 V multiple development life cycle. First one is being a modeling, second one is the prototype, third one is the final product prioritization. In model we have design, build. In terms of development, in prototype we have a design and build, and in final product design and build. Each of these will have a testing phase. Each of these will have a testing phase. So testing is also part of this V. So that is how the test process is closely related with the software V model. This is important. Why? Because we are going to have the testing done along with the test approach or the test scenarios. How we are going to arrive at test approach or test scenarios, or they are with the help of the various aspects of the development life cycle. Those aspects could be requirements, design and the software build itself. So that is how the test process is very much close and related to the V model of the project life cycle. So basically the test process involves a lot of test activities. There are many test design techniques that can be applied, test levels, test types that must be executed, and the test related issues that require attention. The multiple V model assists in structuring these activities and issues. So by mapping this basically the test process into the multiple V model, so it provides an insight into the when one can start activities and what is the time for best in terms of execution. Which test issues are most relevant at which stage in the development process. So organizing the testing in the complex situation of multiple V model is a bit complex task. Suppose design is very tricky and we are not sure about the build is going to work in the prototype. So accordingly we are going to have the test process also a bit complicated. So how we are going to manage this? So test manager needs an overall picture of the relevant test artifacts or the activities and issues. So definitely a bigger picture and system knowledge is very important in terms of mitigating the complexity of the various tasks. Of course, it depends on the particular project. Is very unique to each project, but the general principles of structuring the test process always apply. Okay. So next one being it's an extension of what we have seen in the previous multiple V model, V development life cycle. This is talking in detail in terms of how we have different or multiple V models, like model, prototype, final product has. Like model has failure mechanism and analysis, low level requirements, detailed design verification, and we have uh, simulation, and we have a rare event testing, state transition testing, model checking. All these are all aligned with the various life cycle artifacts. You can see in detail. Similarly, for prototype, we have low level requirements, we have a release criteria on par with that, we have a detailed design verification, we have a system integration test. This all we have seen, right? These multiple V models. So it is same actually in terms of test process, how it is related to software V model. So we have a code review. So for doing the code review, we need to have code available, and on par with that, we are going to have unit testing also, or the component testing. And the component testing requires implementation of the code, and with that, we are going to have the code coverage analysis. It's also a part of the test process, which is aligned to the V model. So that is what it talks about. Okay. The final product also, prioritization or production requirements will be there, and verification requirements also will be there, detailed design will be there, detailed design requirements verification will be there. Accordingly, we are going to have the product certification mechanism, certification testing or acceptance testing, system acceptance testing, regression testing for multiple versions of the software with change in the software only, no requirements or any design modifications, which is impacting the tests. So that's how it is allocated such a way that test processes are aligned with the V model. Okay. The next chapter is about testing design by contract. So what is design by contract? This is another aspect of testing, which is part of the test management. So test management has to define the uh, kind of testing that is going to take care for certain things. This is mostly applicable for object oriented concepts, where class specification is on client and supplier, something like caller or method we use. So this is mostly applicable in object oriented. So there is a term called client and what is it called, supplier. So the methods will be there. The methods are invoked by the calling function. So the calling function is nothing but a client, and the methods are nothing but supplier, which supplies the caller. An approach that uses the documentation only to capture the design, but also to encourage interaction among developers. So basically, through documentation on the models or any specification, we are going to interact, and with the help of that interaction, we are covering the testing. In design by contract, each module has an interface specification that precisely describes what the module is supposed to do. So that interface specification, like ICD or interface control document, will basically talks about what the module is supposed to interface and interact with the other sub modules or the main modules. So Mayer 1997 suggests that design by contract helps ensure that modules interoperate correctly. This specification called a contract, they used to mention or name it as contract. It is not a project contract or something like that. The name itself is contract. So governs how the module is to interact with other modules and systems. Such specification cannot guarantee a module's correctness, but it forms a clear and consistent basis for testing and verification, because we know that the interface what is supposed to be used across the entire system with the help of that specification. So that will ease the P&V. The contract covers mutual obligations, the reconditions, benefits, the post conditions, and consistency constraints. It's called as invariants. Together, these contract properties are called assertions. Testers care about how this contract is enforced. So, how it is going to be executed or enforced in that system under test is what testers have to bother about. So, this is a standard or the process that is being used in the testing. Basically, they use in object oriented systems. Okay. Next, we come to the another part of the embedded software testing. It's called as agile testing. Agile testing Scrum process it is called as. I will not talk in detail about this, but few slides we will try to go through, understand what is an agile development process and what is that agile type of testing that is used in the industry. Okay. So agile proponents believe that current software development process. So the background behind this I will tell you. In many of the industry, they follow typically the process what we have laid out throughout this embedded software testing, all these 30-40 process, whatever it could be, in terms of formal planning, design, testing using various methods, analogies, or any black box, white box, with the checklist, guidelines, and all this. These are all part of the standard process that we follow. But there are certain industries like semiconductor or SOCs or chip manufacturers. They definitely have a process and all that stuff, but as a part of sub process or what is that called, short term to market or time to market when there is a duration is less. So they think that this process is mostly useful or applicable. So in that cases they use this. So they believe that current software development processes are too heavyweight or cumbersome, existing one. So too many things are to be done that are not directly related to software product being produced. So eventually there are many things like certain checklists, guidelines for the sake of doing. Sometimes we do, though it is a small piece of code, we know that it's not going to crash or it's not going to fail any case, but we need to maintain because we are following the process for the entire thing. Doesn't matter how big the complex, how big the system is, or how complex the system is, or how small the unit is, or what is the impact of that unit if it fails. Those things sometimes it's overburden sort of a things. So that is what the agile proponents they believe. Current software development is too rigid. Difficulty with the incomplete or changing requirements, short development cycles, more active customer involvement needed, CMM focus on process. We know that CMM capability in terms of CMM level capability maturity model it is called. Up to 5 levels of maturity models are there, like continuous improvement and all the stuff. We also have a Lean Six Sigma where we avoid waste and all that. All these are getting followed or used actively but they believe that we can improve on that on certain things. So better to use that. So what is that called as agile process? So agile process or methods are considered as lightweight process. It's a people based rather than plan based. Here it is totally surrounding the process or the documentation or the checklist or the guidelines or the underneath process, basically all the activities or the uh, uh, methods that we use than than the people. But in the agile method we basically will have a people based or the team based or the resource based rather than the process based or the plan based. It's a lightweight process. Several agile methods are included existing. It is called no single agile. It's actually wrongly mentioned. It is called as XP. There is another thing. Scrum is the one model we have, and extreme programming XP. That is also one of the model that we have. These are all basically agile methods. A statement of values for the agile process is something like individuals and interactions are taking the priority that is over process and tools. Working software over comprehensive documentation, that is what the value is in the agile process. Customer collaboration over contract negotiation, so basically the need of the customer and its customer's client, etc. All that collaboratively looked into in terms of agile development and responding to change over following a plan. So as we follow the plan, we may have to adopt certain changes into the existing plan. So we don't need to revisit again and all that following the plan with again another set of plan. Instead of that, we can spend on this kind of change that we have for you than the plan itself. There are different agile methods are existing. Scrum is one, extreme programming is another one, adaptive software development ASD, dynamic system development method DSDM. Likewise, there are several methods that are being used. Scrum and extreme programming are most popular. It's also called as rapid prototype development RAD, and there is a website called Agile Alliance. They basically do a research and try to promote this agile development. www.agilealliance.org you can go through. So that talks about agile development process. In particular, we try to understand the agile development Scrum process. Scrum is an agile process that allows us to focus on delivering the highest business value in the shortest time. So basically, it's purely a commercial sort of a thing where time to market, like highest business returns, the shortest time, that is going to be followed. That is going to be used as a process. That is what is called a Scrum process. It allows us to rapidly and repeatedly inspect actual working software. Every 2 weeks to 1 month, this frequency is decided. So during that frequency, it will be repeatedly inspected for the actual software or the working software. The business sets the priorities. Our teams self-manage to determine the best way to deliver the highest priority features. That means we have a prototype that has to be delivered to the customer, and based on customer approval, we are going to have the production and all that. Basically, they use in the production environment this agile development Scrum process. Every 2 weeks or a monthly basis, anyone can see the real working software and decide to release it as is or continue to enhance for another iteration. That is what we do in the Scrum process. You can see a diagram of depicting this Scrum process. That whatever the frequency that we have spoken here, we are going to have the artifacts or the developed items that are available. So that is nothing but the sprint. The sprint is basically a deck of various activities. So backlog test tasks going to be expanded by the agile process, and that is going to define a 30 days framework, and within that 30 days framework we are going to have another cyclic scrum meeting. The scrum meeting will come up with different stakeholders in the team, and they will speak about what is going to happen today, what is going to do tomorrow, and all that. And so we are going to come with an end product at the end of this scrum process on a cyclic way or the defined iterative way. So now coming to the testing process, we may think that testing is needed because it is so short, 24 hours, 1 week, 2 week and all. Development itself consumes maximum time. So where is the scope of testing? Of course, testing can also follow sort of a quick scrum process or quick testing process. It's called agile testing scrum process. So what are roles of tester in scrum? Actually there is no tester in formal scrum process. So there is no definition of tester only. It is part of the development team only. So testing is carried out by the developer with unit testing. So he himself will identify some instrumentation, try to stub or drive the various units that are being used in the scrum. So testing coverage, testing is carried out by product owner or the client, basically the end client or the complete ownership whoever has, he will do the coverage. What piece of software is working, what is not working, how much of the functionality is being covered, what are the requirements that is undergone. Likewise, frequently testing by product owner each sprint, that is a backlog of the various decks. Testing acceptance criteria also will be defined. So that is what we do a agile testing scrum process mechanism. Next type of testing that is called as test driven development. So basically what we do here is test driven development. We execute before we actually do the development on the developed part, and we optimize the development as we progress. So as and when we do a small chunks of development, and we'll try to test it. So we basically test for the failure nature of the particular feature or the processes that we have used. So test driven development means testing executed before actual development, the complete development, and refactoring performed to optimize development. So again and again we will revisit this. So we write a test that fails, write just enough code and repeat it. This is what we are going to continuously do it. So this is what is called as test driven development. So basically it surrounds the testing aspects of the particular unit, and accordingly we are going to have a development. This is what is called as test driven development. Test management and control. So this is also an important thing. Test control. So how are you going to have this test artifacts managed and controlled? So what to do when things happen that affects the test plan? So you may have to revisit the test plan. Something got affected, something got changed. So what are those? Reallocation of resources, changes to the test schedule, changes to the test environment, changes to the entry exit criteria, changes to the number of test iterations, changes to the test suite, changes to the release date. So these are some of the aspects that affects the test plan. How are you going to do it? That is all with the test control. What we are going to do it. So that is what is test management and control. So for test management control also we will have several tools that is called as a test management tool. As I said in one of my earlier session about this, that is TestLink and Bugzilla. I will try to go through that quickly in the next class. We will try to study about test management tool, defect management tool, etc. So that with that we will come to conclusion. We studied about test management, agile scrum test process, test driven development, agile development process, test design by contract, and test process aligning to the software V model. So with that we will end the today's session.